We'll be looking at paired sample t-test, and the case of paired sample t-test is when we want to compare and determine if there is a significant difference between two means, that is, two means of two different variables. That is when we would use paired sample t-test. Now, in this case, we want to check if there is a significant difference between the total death mean and COVID-19 death mean. Now, let's go ahead. Paired sample t-test. And we'll be using just these two. Others are not bold and clear enough. Why? Because we can't use them. This sign is showing that we can only use continuous variables. And in this case, we have just the two variables that we'll be using in continuous variables. That is, they are not categorical, unlike sex, which is female, male, just two things. But in this case, we have both as continuous variables in values, in numbers that are quantified, like they are quantifiable. So let's select both into the box. So we are comparing both means. So this is what we have. The p-value is less than 0.05, which is our significant level. And that means that there is a significant difference between both means. And that means that we'll be rejecting the null hypothesis. Null hypothesis states that there is no statistical difference, or there is no significant difference between the total death mean and COVID-19 death mean. So that is what this means. So that is, in scenarios like this, is when we use paired samples t-tests. There are additional statistics that we can check out. There is normality, there is effect size, there is descriptive. So this is the normality test. So this value tells us that it is not normally distributed. P-value is less than 0.5, so it shows that it is not normally distributed. Note, a low p-value suggests a violation of the assumption of normality. So we don't assume normality because it's low. So that means that it is not normally distributed. And this is the descriptives. The total number of total death recorded, total number of COVID-19 death recorded. Then this is the mean, the median, standard deviation. So total death is showing high variability compared to COVID-19, and then the standard error. Now moving to the effect size. Effect size, according to Cohen's standard, 0.2 shows small effect, 0.6 medium, and 0.8 large effect size. In this case, 0.361 is close to 0.2, so we can approximately say that there is a small size, there is a small effect size, that is, between total deaths and COVID-19 deaths, there is a significant difference between them, between the effects. So both has effects on each other. So that is what it means, and that is that for paired sample t-test.